In this video, I'm going to describe the functionalities of OSI model that provides a guideline how network systems are supposed to communicate with each other. In real life, we use heterogeneous devices with different technologies and access the networks from different places. For instance, I want to communicate with one of my friends on Facebook who lives in Scotland. I'm using my Android smartphone. On the other hand, she is using desktop, which is based on Linux or Windows operating system. So we have to maintain a standard rules or protocols by which all types of devices and technologies will be able to communicate with each other from anywhere in the world. So the main purpose of OSI model is to guide vendors and developers so that the products and software they create can cooperate and provides a clear architecture of a telecommunication system. So in OSI model, the entire task is divided into 7 layers. Each layer is responsible for specific operations. A device can work as a sender and also a receiver. In sender side, the information processing starts from application layer, then transmit it to the presentation layer. So the direction of processing goes from application layer to physical layer, which is known as encapsulation process. And on the other hand, the receiver side works at the opposite direction of the sender. It starts forming the information from the physical layer, then process the information, then transfer to the data link layer and the network layer and so on. So this receiver use the process that call decapsulation. During the encapsulation, each layer of the sender side create a data unit who is known as PDU, that means protocol data unit, that contains the information and uh, the header from the upper layer, and also add a header which is a current layer header. So this is actually known as encapsulation. In order to understand the operations or responsibility of 7 layers uh, of OSI model, I'm going to use an example of sending email. Let's say I'm in front of a computer right now and I want to send an email to my friend who lives in different area like Scotland or India, whatever. So at first I have to open Gmail application, then start writing like, hi, I'm from BracU University. So, and many more. I can write a long email. So I'm basically working on application layer. Now, as I'm using an email application, the responsible protocol is SMTP. That means SMTP will add in the header of the application layer, and the PDU of this layer is called data. The application layer is a layer where actually users are interact directly, like Google Chrome, Skype, Viber, Internet Explorer, and so on. There are lots of applications. So different protocols are responsible for different tasks, like HTTP will use for browsing, and like if you want to transfer file, then FTP will use instead of SMTP. So as we are doing an email application, I'm doing an email, so SMTP protocol is a reliable and required protocol, so it will add to the application layer header. So all the data, all our email and the header of the application layer is sent to the next layer, which is called presentation layer. The first task of presentation layer is translation. So what is translation actually? In application layer, our email includes text, numbers, emails. So those are actually human readable forms. So presentation layer transfer the above information in corresponding binary codes so that our machine can read those information and works. We can do it using different kind of encoding techniques like ASCII codes. Then to reduce the information or reduce the size of the information, size of the bits for faster transmission, we can compress our information. So another work of presentation layer is data security. Using encryption techniques, this layer secure our data so that third party cannot use our data easily. And more frequent usable encryption method is SSL, uh, which is used for data encryption. So in presentation layer, our data is in binary form, uh, which is also compressed, and for security it is also encrypted. So all the required protocol is added to the presentation layer header. The third layer is session layer, which is deal with communication by creating a session between two end users. Uh, it's actually set up a session dialogues between two computers. It could be a host or client or two hosts. For instance, when you are going to access a website, basically your computer at the session layer has to create a session with the server that you are trying to access some information from the server. If the server give you the permission that this is your key that you can access right now, so the required protocol are added to the session layer header and transfer the all the content informations and above layer header and also session layer header to the transport layer. Transport layer provides reliability of communication using segmentation, flow control, error control. This layer decides how much information we want to send in one time. Using segmentation, the whole data which was received from session layer is divided into small units that called segment. The transport layer header includes sequence number that represents segments number, flow control information, and also port number, which allow us to communicate with specific process. For example, we use immense number of processes in our computer like Facebook, email, Skype, etc. So each has a unique port number. Like as I use SMTP for sending email, so the port number is 25. This is unique. So if I use Messenger, Facebook Messenger, I have to use 3478 instead of 25 and so on. So this layer header actually add the source and destination port address. So the next layer is network layer, which is responsible for logical addressing and routing. Each connected device has a network address. You already know this is very familiar to us, that is IP address. So internet protocol is the responsible to logical addressing that actually represents in which network this device belongs. So the header of the network layer contains source IP and destination IP address. Source IP includes my IP address, and destination IP represents the device with which I want to communicate. So the source IP and destination IP is added at the network layer header. Now consider that there is a small network. For instance, this is me, and there is a small network. Those are the routers. Actually, the circle represents router. This is a small networks, and there is a device, the or receiver, with whom I want to communicate. So there are some routes. For instance, I can transfer my packets through this route, or I can use this route, or even also there is a different routes. That means I can transfer my packets through these routes. So there are various routes that we can use to forward our packets. So the network layer is actually dedicated to find the desired route between twin devices by considering cost, that means low cost, or fastest path, or even low traffic condition. And the PDU of the network layer is called actually packet. So each packet contain the origin information along with the headers from above layer and network layer. So it has the all above used protocols and port address and also IP addresses. Data unit in data link layer is known as frame. So this layer is responsible for framing and physical addressing. Basically, all the devices in the world have a unique manufactured address that known as MAC address, which allow us hope-to-hope communication. Hope means next devices or next nodes. As I'm in Bangladesh and my friend is in Scotland, so uh, he is using the internet from different network. So this is quite impossible to transfer my email without any middle network devices. So there are many network devices between sender and receiver. MAC address helps to transfer the information from one node to next node, from that node to another next node, but by following the routing table. Here is an MAC address example that is given. This is hexadecimal format, and the header of this data link layer includes uh, sender's MAC address as a source and next device's MAC address as a destination MAC. And ARP, that means ARP, is the responsible protocol for that. So this layer is also includes some redundant bits in Taylor section with the original information and header that is used for detect error and correct that error regarding the sequence number of the frames and also bits. Due to the noisy channel, there is a high chance that if the sender sends uh, 10100, most probably the receiver can accept this 1001. That means there is an error. So receiver side have to identify the error and have to detect to accept the original form of the information. So data link layer is responsible for this kind of error correction. The final layer is physical layer, which represents bits as data unit. This layer converts bits into corresponding analog or digital signal to transmit through wireless or wired media. This layer actually decides which type of media we are using. That means wired or wireless. If we use wired, then optical fiber or coaxial cable. And also topologies, that means we have a lots of different topologies. So physical layer decides which topologies this device or this networks use, and also the flow modes, that means simplex or half duplex or duplex. Then finally transfer the signal through transmission media, and the receiver side receives this information or signals in physical layer. So now we know how the sender devices process the information and transfer through the media. In receiver side, the device maintains the encapsulation process. That means each layer of the receiver side remove the current header, and after reading the header, it processes the information and then transfer to the upper layer. The lower layer of the OSI model in the receiver side is physical layer that accepts the transmitted information or transmitted signal from wider wireless media, then convert it into corresponding 0 and 1. Then send to them to the data link layer, which will put the frame back together. Using Taylor bits, data link layer detects either there is an error or not regarding the frame bits and sequence number. So if there is an error, then correct it and send the corrected information to the next layer. So network layer is the next layer which reads the source and destination IP address. If it's correct, then reads the routes and process the info packets to send into the next layer, which is transport layer. And transport layer then reads the port number from its header and forward the data which it has received to the respected process. That means specified process, for instance Gmail or Facebook. So as I'm sending the mail, so at the receiver side, the transport layer sends all the information to the Gmail application. Then session layer define is still now is the session is ongoing or not. Then presentation layer is responsible to decode the 1 and 0 to convert to the human readable form and decrypt the mail using same encrypted algorithm that sender side used, and decompress the information to find the original form of the sent email. So finally, application from the application layer, the receiver accepts the information or read the email or interact with different types of application. So here from the application layer, the receiver will accept the Gmail that the sender have sent for the receiver. So this is the actually procedure of receiver side. Now, in the next video, uh, each layer details function will be covered. Thank you.